Hi there, folks. This is the Algebra 1 Unit 2 review, and I'm the amazing Mr. Jansen. So here we go. I'm just going to run through these and explain how to do them. This first one, remember, when we have variables on both sides, we have to get them on the same side first. And my suggestion is you always deal with the variables first. Yeah, I could subtract the 1 or add the 5 first, but don't do that. Try to get the variables together first. I'm going to subtract the 2x from each side because it's always easier to move the smaller variable. So I move the smaller variable. That gives me a 1 over here. Over here, I subtract the 4 minus the 2x, and I end up with a 2x. Now I want to try to get x by itself, so I'm going to undo order of operations. I undo that subtraction first, so I add the 5 to each side. And then after I do that, now I'm going to undo the multiplication by dividing each side. So I'm going to divide each side by the 2 to get that x by itself. And I end up with x equals a 3. And that's it. I can easily plug this back in and double check my work. Okay. The next one, remember, we can work backwards sort of operations. So here I could undo the multiplication, then undo what's in the parentheses. But most of us prefer to just simplify and then solve. So I'm going to simplify by combining like terms by doing my distributive property. So here I'm going to do my distributive property. And that's just a way of actually multiplying. So I'm simplifying a little bit. That gives me a 6h minus 8. Still equals the 4. And now I'm going to work backwards through the order of operations. I'm going to add the 8 to each side, so I undo the subtraction first by adding the 8. Now I'm going to divide each side by the 6. And again, I'm just undoing these order of operations. I'm doing inverse operations as I go, so I find out that h equals a 2. Number 3, there's a couple ways I could approach this. I could treat this like a proportion and say that's a 4 over 1 and cross multiply. If you decide to do that, that's fine. I'm going to take the more literal approach here. Remember that whenever I have a big giant fraction like this, it's implied that that numerator is in parentheses. So if I'm working backwards sort of operations, I have to undo the division before I undo what's in the parentheses. So I'm going to multiply each side by 3. So I multiply this side by 3. I multiply the other side by 3. And what happens here is on this first side, the 3's just cancel each other out. Okay, and that's the mistake that most students make is they try to distribute that 3. Now the 3 cancels out, so there's no 3 left to distribute. I'm just left with the g minus 2 over here. Okay, please don't distribute that thing. Cancel it first, so I get g minus 2 equals a 12. And now I can undo what was in the parentheses essentially and add that 2 to each side. So I find out that g equals the 14. Okay. This next one, the first thing I'm going to do is simplify. So I'm going to simplify by doing my distributive property. So here I'm going to distribute. And keep in mind I'm distributing a negative 2 there. Here I'm going to distribute that negative 1/4. And again, it's a negative that's being distributed. So with this guy, I really don't have anything to distribute here. I can drop these parentheses. They're not doing anything. So now this gives me a minus 2y minus 6 equals, over here that gives me a negative 1/2 y plus 1/4. And just be really careful with your signs here. And now from here I could maybe combine some like terms. So maybe the 1/2 y minus the 2y. Maybe I'm looking at that 1/2 and the 2 and I don't really want to combine those because I'm not sure how to do it. And that's okay. We could get common denominators and work our way forward. I'm just going to combine the easy ones. And then I'm going to look at this and say, man, this sure would be a lot easier if there weren't any fractions here. And remember, the trick that we have with fractions, we can eliminate all of them by multiplying through by the common denominator. So the common denominator between all the fractions listed is a 4. So I'm just going to multiply each side by 4. And yeah, that involves my distributive property. So I multiply everything by 4. So I do the 4 times the 1/2 and I get a 2. Here I do the 4 times the 2 and I get an 8. 4 times the 3 and I get a 12. All right? Over on the other side, oh, I forgot to write my 4 over here. That's a little scary. I got to distribute the 4 as well. So I distribute it. I get a negative 2y and a plus 1. And you notice that everything I have is way simpler now. I can combine some of these like terms. I get a negative 6y minus 12 equals a negative 2y plus 1. And now I'm going to get the x's on the same side first. I always move the smaller x value, which is the negative 6. So I'm going to add the 6y to each side. And I'm running out of space here. Let me take this guy up here a little bit. So over here I end up with a negative 12 equals, that's going to be a 4y plus 1. Now I can subtract the 1 from each side and go from there. Okay, so I get a negative 13 equals the 4y. I'm going to divide each side by that 4. And again, whenever I show division, I show it like I'm setting up a fraction, because now I can see my answer. It's y equals, it's negative 13 over 4. And you can just leave it as an improper fraction like that. Okay? The next one, same kind of thing as that one step I took in the previous problem. The second I see fractions, I think, man, it sure would be nice if I didn't have all those fractions. Let me rewrite this, guys, so I just have a little bit more space. But remember, to undo the fractions, to get rid of all the fractions from any equation ever, all I have to do is multiply through by the common denominator. So in this one, the common denominator is 18 between all three fractions. So I multiply this side by 18. I multiply this side by 18. All right. And once again, when I'm multiplying this, I have to distribute on that first side. So 18 times the f over 6. Keep in mind that a fraction bar is just a division bar. Okay. So when I see f over 6, it's like 1f over 6. It's like times 1 divided by 6. So 18 divided by 6 is a 3. So it's just 3f. Okay. Here, same thing. When you look at a fraction, it's multiplication and division happening simultaneously. So it's times 2 and divided by 3 at the same time. Do the division first. So here, when I do the 18 times the 2/3, I do divided by 3 and then times 2. So 18 divided by 3 is a 6, times 2 is a 12. Okay, that's the mental math approach to this. Same thing on the other side. 18 divided by 18 is a 1, times the 7 is a 7. And now I can finish solving this thing. Once we get rid of those fractions, this thing is much, much easier. All right, so always get rid of the fractions by multiplying through by the common denominator. So here I get a negative 5, and now I undo the multiplication with division. I divide each side by the 3. Again, I ran out of space a little bit here. That's okay. So I get f equals, looks like a negative 5/3. Okay? This one, it says I have 16 coins. Lavender Gooms has 16 coins in her pocket that are either dimes, quarters, or nickels. If she has twice as many dimes than nickels and 4 less quarters than she does dimes, how much money does she have in her pocket? And so there's a lot of components to this. I'm going to start off by thinking about the nickels, dimes, and quarters. So I've got nickels, I've got dimes, and I've got quarters. All right? And so here's the thing. I don't know how many nickels there are, so I'm going to call it n. All right? N for nickels, because that's a great variable to use. You can use x if you want. It doesn't really matter here. But then when I think about the dimes, I don't want to say dimes equals d. The whole point here is I only want one variable to deal with, and I've chosen n. So then the thing that it tells me in this problem is it says I have twice as many dimes as I do nickels, which means if n is the number of nickels, the number of dimes is going to be twice that, which is 2n. All right? And then the next thing it tells me, it says, hey, the number of quarters is 4 less than the dimes. So we have 4 less quarters than I do dimes in this scenario. So if the dimes is represented by 2n, the quarters is 4 less than that, so it would be 2n minus 4. And see, the idea here is that everything is written in terms of one variable. Now I can set up an equation. And when I think about this equation, it says that I have 16 total coins. So if n is the number of nickels plus 2n is the number of dimes plus 2n minus 4 is the number of quarters, that should equal a total of 16 coins in her pocket. All right. So now I'm just combining like terms. I'm going to simplify and then solve. When I combine these like terms, that gives me a 5n minus 4 equals 16, and now I'm just undoing those order of operations. So I add that 4 to each side. I end up with a 5n equals 20, and now I can divide each side by the 5. All right. Now, having n here is great, but that still doesn't answer the question. Make sure we're answering the question here. N is 4. That means, when I think back to the beginning of this problem, I was talking about these different variables. Well, now I know that, okay, that means the number of nickels, so the number of nickels, going back to the beginning, is 4. The number of dimes is now 8 because it's 2 times that. And the number of quarters also happens to be 4 because it was 4 less than the number of dimes. All right, but now I still haven't answered the question. Ask how much money does she have in her pocket? So I have to think about this and say, wait a minute. This guy right here, 4 nickels, that's 40 cents, right? Or sorry, that's 20 cents. crazy Mr. Jansen. That's 20 cents. Oh, 8 dimes, that's 80 cents. 4 quarters, that's $1. And so I add this up and find out that I have a total of $2. That answers the question. So make sure you're taking this through all the way to the end. A lot of components to this and just understanding how these things are related. Okay? So look at the next one. 3 consecutive even integers. Okay? Remember, integers are when we're counting up by 1. So consecutive integers would be n plus 1, n plus 2. So if I want consecutive even integers, I need to skip one of these. So like here, if I'm thinking about consecutive integers, here's the, oh boy, I wrote an m there. N plus 4. So see how I'm adding 1 each time? Alright, that's how I get from one number to the next. So if I only want the even integers, I essentially just skip every other integer. Okay? So 3 consecutive even integers would be n, n plus 2, n plus 4. Okay? So let me condense that down just a little bit. So I've got n, n plus 2, and n plus 4. Those are my 3 consecutive even integers, and then it says those should add up to 300, so that means n plus the n plus 2 plus the n plus 4 should equal the 300, and now I just have to simplify and then solve. So I combine like terms, that's a 3n plus 6 equals 300, and now I can solve this thing by undoing order of operations. I subtract that 6 from each side, and I end up with 3n equals 294, and then I divide each side by the 3. And so when I do that, I find out that n equals, looks like a 98. But now that still doesn't answer the question. That means the first integer is 98, the next even integer would be 100, and the next even integer would be 102. And what's nice about this, I can instantly check that, add them up. They do add up to 300. All right? This one, we want to convert each to the given units. And so we always start with what's given. So I start with the 260 seconds. And then I just always multiply this by a fraction. So I'm going to multiply this by a fraction. I have to put seconds in the denominator because I need to cancel out. I want to change this to minutes. And I know that there are 60 seconds in 1 minute. Okay, and that's the setup for this. And this is essentially a fraction over 1. But now what happens is these units cancel, the seconds cancel. You see that I'm now going to be left with minutes. All right? And really this is a job for my calculator. I'll show the extra steps here. But it's numerator times the numerator. So 260 times the 1 is 260. And that's minutes. The denominator, 1 times 60 equals 60. And now it's just a job for my calculator. I plug this into my calculator. I end up with 4.3 repeating. So you could say 4 1/3 minutes. Or you could say 4.3. If you round it off, that's fine for this one. Okay? So 4.3 minutes. All right? This one. Again, you start with what's given. You start with those 5 pounds. And again, that's a fraction over 1. Now I'm going to multiply by a new fraction. I have to put pounds in my denominator, so these cancel. And I want to convert it to ounces. All right? And so I know that there are 16 ounces in 1 pound. And so what happens, once again, is the units cancel. The pounds cancel. I'm going to be left with ounces. And now I multiply straight across. And again, I'm going to show this. But I do 5 times the 16, which is 80. I do 1 times the 1, which is 1. So I have 80 ounces over 1. Well, yeah, that just simplifies to 80 ounces. And that's it. This becomes complicated when we look at something like this next example. This one's a little bit tricky, all right? It says a cheetah ran 300 feet in 2.92 seconds. And we want to know what's the cheetah's average speed in miles per hour, all right? And the big discrepancy here, this would be easy if they said, what's the speed in feet per second? Because that's what I have. I have feet per second right here. I have feet in seconds. The problem is I want that to be miles and hours instead. So what I have to do is I have to convert each of these before I can set up my ratio. All right? If I wanted the speed in feet per second, I just have to divide these and get a ratio. All right? But I have to convert them to miles and hours first before I can come up with that ratio, before I can come up with that speed. All right? So I start off with the 300 feet. And once again, that's over 1. I'm going to multiply by a fraction. Feet goes in my denominator. Miles has to go in my numerator. And I know that there are 5,280 feet in a mile. If you don't know that, I'll give you those kind of conversions on the test. So don't be too worried about that. All right? And so when I multiply straight across, I just say, okay, 300. Again, the feet cancel. Sorry, I should show the feet canceling. So when I multiply numerator times the numerator, that's 300 miles over 5,280. And from here, I could plug that into my calculator and get a decimal, all right? But I really don't have to do that just yet, all right? This is essentially in miles. I could leave that as a fraction. I could reduce the fraction. In fact, if I reduce this fraction, let me see what it is here. 300 divided by 5,280 as a fraction, it's going to be 5 over 88, all right? And again, that's just in terms of miles, all right? I could do the same thing then with the seconds. I want to convert this. It was 2.92 seconds. And again, that's over 1. I'm going to multiply that. I need seconds in my denominator. I want to change it to hours. Now, I can't jump right to hours, so let's say, okay, seconds I can convert to minutes. And then here I can convert minutes then to hours. And again, it's just a game of canceling out these units. I know there's 60 seconds in 1 minute. I know there's 60 minutes in 1 hour. And then we can see the progression of, okay, the seconds cancel and I'm left with minutes. Now the minutes cancel and I'm left with hours. All right? And once again, I do numerator times the numerator, so I get 2.92. And then again, this is going to be in hours over. When I do the 60 times the 60, I get 3,600, so 3,600. And again, I could just leave it like that. If I want to try to reduce this, I'd have to multiply the numerator and denominator by 100 and then reduce. You can just leave it as a fraction. If you want to plug it in and put it as a decimal, that's fine also. But if I were to put this as a fraction in simplest terms, the simplest terms fraction is not great. It ends up being 73 over 90,000. And that's just me doing that work on my calculator. Again, just leave it as this first fraction, that's fine, but that's in hours. And it makes sense. You know, when you think about 300 feet is not much of a mile. You know, 2.92 seconds is not much of an hour, so we get these really tiny fractions. But now if I divide these two things, if I take the miles and divide it by the hours, I'll have miles per hour. And this is going to be just a job for my calculator. You just have to be really careful. If I want to do this, the 5 over 88, slap that in parentheses, and then divide it by, and then this guy, 73 over the 90,000. Okay? And again, this is just a job for my calculator, so I plug it in and say 5 divided by the 88, and then divide that by the other fraction, which was the 73 divided by the 90,000. And again, if you have these written as decimals, that's okay. You'll just take the two decimals and divide them, and we get approximately 70 miles per hour. All right? Again, if you had rounded those off to decimals, keep a couple decimal places, you should be pretty close to the 70 miles per hour. If it's off by a little bit, that's okay. All right? But that's a pretty challenging question. These guys, we're just setting up, we've got proportions here, so we're just going to solve the proportions by cross-multiplying. So again, when I do cross-multiplying, I say, okay, negative 5n times the 2 is a negative 10n equals 5 times the 4, which is a 60. And now I'll go ahead and solve the equation that's left. I divide each side by the negative 10, and I find out that n equals a negative 6. All right? The next one, once again, I cross-multiply. I say, okay, 6 times the 2x plus 1 equals 34 times the 3, which ends up being 102. And now I want to solve, so I simplify and then solve. I'm going to distribute that 6. That gives me a 12x plus 6 equals a 102. I'm going to subtract the 6 from each side. That gives me a 96, and now I can divide each side by the 12. So I find out that x equals an 8. Okay? The next one, again, same kind of thing. I'm going to cross-multiply. So I cross-multiply 3 times the negative 10a is going to give me a negative 30a over here. And again, I would show this step 8 times the negative 4a minus 1. And now do my distributive property. Students tend to make a lot of mistakes when they try to do the distributive property right away. Lots of sign errors occur that way. 30a. Now, over here I'm going to get a negative 32a minus 8. And then from here, I'm going to add the 32a to each side. I got to get my variables on the same side. So I end up with a 2a equals a negative 8. And now from here, I just have to divide each side by that 2. So a equals a negative 4. And again, any one of these we can plug back in and check them. This one, the 3x plus 1 times the 3, so 3 times 3x plus 1 will equal the 5 times the x minus 5. All right, again, I just show that step and say, all right, now I'm going to distribute. All right, I save that distributing for the next step because I don't want to make any silly mistakes here. So I get a 9x plus 3. Over here I get a 5x minus 25. And then I want to get my x's on the same side. I'm going to go ahead and subtract the 5x from each side. Always try to deal with the variables first. It just makes things work out a little bit nicer. Now I can subtract that 3. And now I'm going to divide by that 4. Almost said negative 4. By the positive 4. Which ends up giving me x equals a negative 7. Okay? All right, the next one, we're talking about a scale drawing here. So again, when we're talking about scale drawing, I always start with the scale that's kind of given here. So the scale that they gave me is 1 inch goes to 3 feet. And then it asked me to convert two measurements. And again, because this is set up as inches over feet, the next one has to be inches over feet. Inches is the thing I'm looking for. 21 feet is the actual length of the room. And then I'm going to do the same thing with the next dimension. I say 1 inch goes to 3 feet equals how many inches, I'll call it y this time, go to 18 feet. All right? And now I just cross multiply. That's a 3x equals a 21. And then I divide each side by the 3. So I find out that x equals 7 inches. Here I cross multiply and I get 3y equals the 18. And once again I divide by the 3. And I find out that y equals 6 inches. And so as I'm drawing this scale drawing, the room that was 21 feet by 18 feet, in my drawing is going to be represented by 7 inches by 6 inches. Okay? Next one, a flagpole casts a 32-foot shadow. So let me draw my flagpole. I always use like the little Mario flagpole. That's the best I can draw right there. All right, yeah, that is fantastic. And it's cast in a shadow, so here's the shadow. And remember, when we cast these shadows, we're essentially just setting up triangles. So it said it had a 32-foot shadow. That was close. And then a 6-foot tall person. So here's my person. They're 6 feet tall. They're 6 feet. And they're casting a 16-foot shadow. And so really, these things form similar triangles. I don't know the height of the flagpole, so I'm going to call it x. And I just compare. I say, okay, the height of the flagpole compares to the height of the person. And then the shadow of the flagpole compares to the shadow of the person. And again, as long as we're consistent in terms of the setup here, you could do x over 6 equals 32 over 16. Or you could do something like the height of the flagpole compares to its shadow, so x over 32 equals then 6 over 16. And either way, you'll get the same answer. We're going to go ahead and cross multiply. So I cross multiply, I get 192 equals the 16x, and now I divide each side by that 16. And so when I do that, I end up with x equals, let me see, let me use my calculator for this one. Looks like a 12th. All right, so the flagpole is 12 feet tall. Alrighty? For this one, it says to solve for y. So again, we just want to move everything else that's there. Again, when we're solving equations, we work backwards sort of operations. So right now, I can undo the addition or subtraction, then the multiplication. So I'm going to subtract this 4x from each side. And the thing that's tricky about this is, yeah, this stays negative 3y because those cancel out. But here, I can't actually do the subtraction. I've got a positive 15 and a negative 4x. You can write it as 15 minus 4x or a negative 4x plus 15. All right? I always tend to write the variables first. It makes things look just a little bit cleaner. And now I divide each side by the negative 3. When I do this, I have to do my distributive property. So here I do negative 4 divided by negative 3. And notice it's set up like a fraction. It's negative 4 over negative 3, which is a positive 4/3. And then here, 15 divided by the negative 3, that's a minus 5. Okay? So again, make sure you do your distributive property to finish simplifying that thing. This one, same kind of thing. It's kind of set up in the same way. I subtract the 5x. And once again, I'm going to follow the same protocol that I did before. I'm going to say, okay, 1/2 y equals, I'm going to write the x first. So I'm going to do negative 5x and then the minus 3. And now to undo the 1/2, don't divide by 1/2. Multiply by 2 instead, okay? Always undo fractions in terms of multiplication. Things will always work out better if you do it that way. So here it cancels, I get y. Here I have to do my distributive property. That's a negative 10x minus 6. And that's it. For this guy, I want to solve for b. So once again, I have mx plus the b. So to undo that addition, I'm going to subtract the mx. And it doesn't matter if it's a big chunk like that. I subtract that entire thing from each side. So I subtract mx from each side. I end up with y minus mx equals. Over here, I'm just left with b. Well, that's the thing I wanted. b equals y minus mx, and I'm done. Okay? This guy, same kind of thing. Right now, I want to solve for h, and there's really two big things that are happening to h. I'm adding this big chunk, and I'm multiplying by this big chunk. But again, when you're solving equations, you've got to work backwards the row of operations, so I have to undo the addition first. So I subtract this big chunk first. So I subtract the 2 pi r from the 2 pi r squared from each side. So I end up with a minus 2 pi r squared. I just literally write that subtraction as subtraction. I don't simplify. I don't do any of that stuff. I just leave it as subtraction. Over here, they cancel, and I get 2 pi r h. And now I'm multiplying by this big chunk of 2 pi r. So to undo multiplication, I divide. And whatever I'm multiplying by, I just divide by this whole chunk, the 2 pi r. And then from here, instead of doing my distributive property because it becomes a real mess, I'm just going to leave this as a big giant fraction. This guy minus this guy divided by this other guy. Alright, so I just leave it as a big giant fraction. It was already kind of set up that way. Now this thing is solved for h. And that's it. Okay? For these guys, tell whether the percent is increase or decrease, and then just find the percentage by which this thing has changed. So if the original amount was $99.50 and the new amount is $92.50, this thing has obviously decreased. So this is a decrease. And then to find the percentage decrease, I just say, okay, it went down 7 units, right? So when you subtract those, you get a 7. So the change is 7, and we just divide by the original. Okay, to find a percentage, we just divide this thing. When we divide it on our calculators, it's obviously going to come out as a decimal, and then we just convert that decimal to a fraction. So this one, I got 0.07035, okay, and that keeps going. We just convert that to a percent by moving the decimal 2 places or multiplying by 100, and I end up with approximately 7%. All right, and that's it. So this was a 7% decrease. The next one, the price went from $19.25 to $22.75, so it went up, so that's an increase. And then looking at how much it increased, it went up by $3.50. And you can do that on your calculator by just subtracting the two things if you're not comfortable doing that in your head. So it went up by $3.50, so I put $3.50, and I just divide that by the original, which is 19.25. Again, I plug this into my calculator. I let it spit it out as a decimal. I get 0.181818, and that's just a repeating decimal. And then I just convert it to a percentage. I multiply by 100, or I move the decimal 2 places. So I get 18 point, we'll just round it to 18.2% for right now. Okay? This guy, there's a new video game on sale for 10% off. If the original price of the game is $59.99, what is the sale price of the game? So remember, we can find the percent. We could find 10% of the $59.99 and then subtract it. Or we can say, okay, instead of paying 100% of the cost, I've got a 10% discount, so I'm only going to pay 90% of the cost. All right? And so find 90% at something, I just write it as a decimal, so 0.90 or 0.9, and I multiply that by the $59.99. Okay? And that's our short, quick, easy way to do these, is we just treat that percentage as a decimal, and we multiply to figure out the value. So I end up with 53.991. I'm going to round it to 2 decimal places because I'm talking about money. So 53.99. All right? This one, we do the same kind of thing, but we have to work backwards. It says there are 21 females in an Algebra 1 class. 75% of the class is female. How many students are there in the class? So the number of students in the class, I'm going to call that X. Well, normally we'd say, okay, 75% of the class equals the number of females. So 75% is 0.75 times the total number in the class should equal 75%, which is the 21. See, this 21 already represents 75% of the population. So now I'm working backwards. So now I'm going to solve this equation by dividing each side by the 0.75. All right. Again, if you want to set it up and do it as the is over of equals percent over 100, that's perfectly acceptable. You can do it that way. This is just a little bit faster, a little bit smoother in terms of that. So that's 28 students in the entire class. All right. Last one here. It says the price of an item costs $64 is increased by 10%, but then reduced by 10%. Is the final price of the item equal to the original price? And we want to explain our answer. Okay? And it's really interesting. At first glance, you're probably thinking, well, of course it's going to be similar. Went up 10%, down 10%. It's going to be the same. But let's do the math on it. So if I want to increase this by 10%, so now I'm basically going to come up with, I started with 100% of the cost. I increase it by 10%. I'm now going to have 110% of the cost if I increase it by 10%. So if I want to find 110% of 64, I say, okay, that as a decimal is 1.10 times the 64. So the new price after I increase it by 10% is going to be $70.40. Okay, so that's my new price. But now I'm going to take that new price and do a 10% off kind of discount. All right, so if now this guy represents 100% of my value, I'm now going to pay 90% of that. That's what would be represented by a 10% discount. So I'm going to do 0.90 times my price, which is the $70.40. And when I plug that into my calculator, I end up with $63.36. And so the answer, the obvious answer to this is no, the prices are not the same. But the question becomes, why are they not the same? And the reason is because I'm taking 10% of two different values. The first time I was doing 10% of the 64 and adding it. The second time I'm doing 10% of a totally different value, doing 10% of the $70.40. So I'm doing 10% of two completely different values, which is why they don't match up. Okay? And so the answer here is no, and the reason is because we're using 10%. We are, I'll say, looking at 10% of different values, or different initial values. Okay? That's it. Good luck on your test tomorrow. Please remember to study some of the things from the previous units.